Hello everyone. Today we are using factoring as a method to solve quadratics. And this is very important because most of you have been factoring quadratics for a while, and it becomes new when someone says you're going to use factoring as a way to solve a quadratic. But that was really what you were doing the whole time. When you learned how to factor, you were really getting the basis for solving a quadratic equation. So the same factoring methods apply, and I'm going to show you what you have to do with these quadratic equations, how to factor them, and then how to get your solutions, your zeros or your roots. So I'm going to start off with a simple binomial. For my first example. So here we have a quadratic equation, right? We know when we have an equal sign, we're dealing with equations. We're no longer dealing with just expressions, because some of you may have been factoring, and when you were factoring, you were just given a binomial, you were given a trinomial, and you were just told to factor. Now we have an equation, okay, when something is set equal to something else, expressions are set equal to each other, and now we have that equation. We see y is equal to x squared minus 81. We know that we have a binomial on the right side of the equation, right? And that binomial, we have to try and determine what type of factoring we need to use in order to factor that binomial. So automatically, I know that x squared is a perfect square, 81 is a perfect square. I have a subtraction sign, right? And I'm thinking that subtraction sign means that I have to use a specific type of factoring, and the fact that these are two perfect squares. If you can guess it, go ahead and guess it now. If you chose dots, you are correct. Dots or dots, difference of two squares or difference of perfect squares. If you have chosen that method, then you are well on your way to solving this quadratic equation. Okay, so we're going to use DOPS factoring, okay? And DOPS factoring just says that we set up our two parentheses, right? But notice we have an equation sign, an equal sign, right? So therefore, we're just going to rewrite that equal sign. Now, in DOPS factoring, I take the square root of the first term and I place it in the parentheses. Then you see this subtraction sign here, so automatically when it comes to DOPS, we're going to have one subtraction sign in the middle, one addition sign, because that's the only way you can get a negative, is a negative times a positive, gives you a negative, and then the square root of 81 is 9. See, we have successfully factored our binomial here. And so it's still equal to y, and so now this next step is important. When you were looking for the solutions on a quadratic, when you were looking for the solutions of a parabola, of a quadratic function, if you noticed, y is always equal to 0 when we're looking for our x values. When we're looking for how many times that parabola touches the x-axis, where it's set at y is equal to 0 and x is some number. So automatically we know that it's going to touch the y-axis, right? Because when you're looking for the solutions of a quadratic, it's touching the x-axis only. And so for y is going to be 0. So I can automatically turn this y into a 0. Right? And I'm just going to rewrite the rest of my equation because we know that y is equal to 0 when I'm going to start solving. But I'm not going to start solving yet. We just know that y is going to be equal to 0. Okay, now here's something very interesting I want you to pay attention to. We know that y is equal to 0. So this whole equation is equal to 0. And I could represent that just simply by like erasing that y and these y's and replacing them with 0. But I did it at the end because I wanted you to know that when y is 0, then we can find our x. Because on the parabola, let me just graph that, right? This is our y-axis, this is our x-axis. We know that when the parabola touches the x-axis, Y is 0. So these are our solutions when it touches the x-axis. So because y is 0, I can just change it automatically. And now this whole equation is set equal to 0. So since I know that the whole equation is set equal to 0, what I have to do now is I have to actually split these two binomials up because I'm going to solve for them. So in order to do that, the first thing I'm going to do is draw a line down here, and I'm going to split my equations up. So I'm going to write 0 is equal to x minus 9, and then I'm going to write 0 is equal to x plus 9. Now the reason both of them get to 0 is because, again, the whole equation is equal to 0. So if I can't just put one of them is equal to 0, both of them have to be equal to 0 because they were originally all a part of the same equation. So we can't just separate one equal to 0 and not do it to the other. It's unfair. So when you get down to this step, it's just your simple additive inverse solving for x. We know that we got x minus 9. We want x alone. So we're just going to do the inverse to both sides of the equation. Remember, we're being fair. And we're going to be left with 9 is equal to x. And then when we do the same thing on the right side, this cancels out, and then we're left with x is equal to negative 9, okay? And these are our solutions, all right? X is equal to 9 and x is equal to negative 9. And again, if we looked up a quadratic function on a graph, if we looked at a parabola, we would see that it would touch the x-axis at negative 9 and 9, and the y would be 0. That's why we don't need to find the y, and that's why we can change the y to 0 in the equation. We're going to go through a few more examples just so you can get some different viewpoints of different factoring types and how they all relate to the same thing. Here is my next equation. Okay, so the first thing I want you to think of is, what kind of factoring would you use to factor this problem? If you're thinking trinomial factoring, then you are correct. We can't use perfect square trinomial factoring because the first and third term aren't perfect squares. We can't use DOPS factoring. There is no GCF here. And so, some of those factoring methods are right out of the window. So we're going to try trinomial factoring to begin with. So I'm going to rewrite my y equals, okay? And I'm going to set up my parentheses. Now, some of you also may be seeing problems where it says f of x, for example. That's the same thing as y. I just want to make sure you're clear on that. If you're getting any of that, or g of x, right, you're going to see a lot of, it's the same thing as y, is the function of x. The purpose of x is to get you y. So just making sure you're clearly not getting confused if that's on your problem set. But if it isn't, you're good. So let me just get rid of that. Alrighty, so I'm going to use trinomial factoring. So remember, in trinomial factoring, I have to find out what are the factors of 8 that will either add or subtract to give me negative 6 of my second term. So the factors of my third term that'll add or subtract to give me my second term. So, sorry, before I do that, I'm going to write x in both sets of parentheses because that's what gives me my x squared. Now I can go to my third term. The factors of 8, right, are 1 and 8. Well, that'll never give me negative 6. 4 and 2, that'll possibly give me negative 6, most definitely. And that's it. So I know that I'm going to write a 4 in here and a 2 in here. And then interestingly enough, negative 4 minus 2 will give me negative 6. Negative 4 times negative 2 will give me positive 8. So therefore, this will be 2 negative inside of my parentheses. Okay. And then remember, we talked about, well, we're not done here. We know that when we're trying to solve for x, y is equal to 0. So I can automatically set y equal to 0 and then rewrite the rest of my equation. You'll just get faster at this the more you do it. Okay, let me just check mark this. For the one we used, I'll cross this out. Alrighty. And then, again, I got to rewrite this because I have to give both. Now I write my line going down the middle. Both equations have to be set equal to 0 in order to be fair. Both binomials. Okay. And we're just going to do the additive inverse here. Let me get a different color. Let's go with a gray. Plus 4. Cancel it out. X is equal to positive 4. And plus 2, plus 2. And x is equal to 2. And therefore, we have solved and found our solutions. Our solutions are, if we write it like this, x is equal to 4 and x is equal to 2. Because we automatically know, again, that y is 0 when it touches the x-axis and when the parabola touches the x-axis. There we go. I'm going to do one more. This example is going to include a perfect square trinomial. Okay, so for this example, I'm going to write this f of x notation just in case you see that notation, but always remember it's y. Okay, it is y, so f of x, x squared. Remember, just right on the side, f of x, it just means y. It's the same thing, okay? So f of x is equal to x squared minus 12x plus 36. Here I have a perfect square trinomial. Okay, here I have a perfect square trinomial. So I am going to factor this. Now, if you don't remember how to do perfect square trinomial factoring, then you need to get a refresher on that video, okay? But it's very simple. We are going to rewrite, right? We're going to rewrite our parentheses in order to factor. So we take the square root of the first term, so that's x, and put it in both parentheses. We take the sign of the second term and put it in both parentheses, okay? And then we take the square root of the third term and put it in both parentheses as well, okay? And here we are with our perfect square trinomial factored, okay? And so automatically, sometimes I know that they've told you to write your perfect square trinomial as a binomial squared, but we're not going to write it like that. We're just going to leave it as is because, remember, both binomials have to be set equal to 0. Okay? They both have to be set equal to 0. So we're not going to write it in the binomial squared form. You'll see that on other Regents exams or other questions, of course, but that's a specific purpose. Right now, we can leave it just as is because we have to set this equal to 0. So f of x, remember, it is y. So you could change that whole thing into 0. You can change that whole thing into 0. Okay, it's the function of x. The function of x, or the purpose of x, is y. It's to get you y, right? So just making sure you will know y is the same thing. We change that to 0. We set this entire thing equal to 0. Right? So I'm just going to then change, right, draw my line going down and then make sure both sides is equal to 0. Okay, and your regular one-step equation process here, your additive inverse. Something special to note here as well is that these x values are the same. So therefore, a perfect square trinomial, if you graph it, you may notice that it hits the x-axis at that same point, at x is equal to negative x, meaning that it may have just one solution. Okay, just one solution. So those are my 3 examples. You must get good with your factoring in order to be able to factor. Always remember that f of x is equal to y, just in case you have the difference there. It is the same thing. And set both binomials equal to 0. And then you're left with a one step. So rewatch this video if you need help. And see you again later.